And here we are at the makeshift lab. I'm actually using my 3-year-old daughter's workstation to conduct this very highly technical research, so excuse the pictures that we're seeing at the moment. Now, what I'll demonstrate first off is the capture of an FTP transfer session, and then I guess we'll go straight into the capture of a secure FTP transfer session. So I've already added a couple of hosts to FileZilla. The instructions for installing and configuring FileZilla and the hosts are in the user guide. The first one is just a server that I've got access to on the internet, which is accessed via FTP. So what I'll first do is get our trusty Wireshark. Wireshark is probably the most popular open source packet sniffing tool on the market, and we'll start a capture session. Now there's probably a whole bunch of background processes and things running, so please excuse what comes up in the capture session, but I'll try and jump straight to the FTP very quickly and capture the appropriate packets, and then we'll pull them apart. So I'm just starting the session now. Okay, and running into FileZilla, we'll go to Site Manager and we'll connect to the FTP site. Okay, as you can see over on the right hand side here, we've actually got a successful connection. So now we'll stop our FileZilla capture session. Okay, so now we have all the packets that were transmitted during the capture session, and it doesn't take very long at all to highlight passwords. So what you can see here is that the FTP command pass, which sets up for a password response, has captured the password, and the FTP command user has captured the username. So using both of those details, we can then go to the destination, which is clearly identified by the IP address in the capture details, and log into that server. So as you can see, clear text, very insecure. What we'll do now is actually use the little Java app that's been created. So I've got a little directory here. It's got an FTP test client. The source code and compilation information is available in the user guide, but basically it's all ready to go. So I'll just run it. So just using the Java interpreter, we'll run the FTP test. Oops, hang on. We better start the capture. So we'll start a new capture. We'll discard those savings. So continue without saving. Okay, so the capture's starting. Let's run a little utility, and away we go. Okay, as we can see in the background, a whole bunch of stuff. We're now uploading a file, and it's finished. So what we'll do is stop the capture. Okay, so here's the captured information, and again we find that we've got the user, the host, the password, not necessarily in that order of course, and now we can see the whole set of commands that has been transmitted. We've changed directory, entered passive mode, and now we've asked to store a file called constants.php. Okay, so now as we go down the transfer, we actually have this FTP data, and this FTP data protocol is the actual transfer information in clear text. So in here we've got the clear text and all of the data. So to pull out this data is a very simple process, and what this data actually is a constant.php file for a website that contains database IP addresses, connection strings, and username and passwords. So although we have that in a file, because we're using a clear text protocol to transfer this to our web server, we've just exposed that database and connection details to a wider audience should someone be sniffing on that wire. So as you can see, FTP is a very common protocol used by I guess commercial web hosts to allow their clients to upload details. You can easily expose your website to I guess a wider range of exploitation database, you know, someone getting in, grabbing all the content out of your database. Okay, so now what we'll do is we'll go back to the presentation. I won't return back to the wider the studio. We'll stay here and we'll have a look at the findings. Username and passwords are insecure when transmitted by FTP. Data uploads, downloads, as we've just demonstrated, are easily pulled apart and stolen. FTP based is best used for file and software distribution sites using anonymous access, and you'll find quite a lot of websites that I guess are tossed up between the HTTP transfers or FTP transfers. Quite a few of them now will just jump off to an FTP anonymous site, which usually is just secured by an email address. Okay, so now we're going to jump into an FTP communication demonstration using the FTP S protocol, so adding some SSL encryption. Okay, sorry, just got the word from the media manager to rotate the monitor. Okay, so what have we got here? Exit there. Okay, whoa, back, previous. Okay, so what we'll do is jump back to Wireshark and our FTP client. So we'll close the session that we've just had. Close tab. Oops. Close tab. Yeah, that's alright. Okay, so what we'll do now is start a new capture. Okay, continue without saving. We'll go in and we'll connect to a freely available SFTP site, which is cyberspace.org, using a different protocol. Okay, as you can see up there, we're using port 22. The SSH fingerprints come through, so to access this site we must accept that, which we've done now. Okay, so it's actually failed the connection because my password's incorrect, but let's have a look what we can see from that session. Okay, the first thing we've got is we've got a handshake between server and client for the SSH 2.0 protocol, OpenSSH 5.9. Okay, so we've now got an encrypted session between client and server, and you'll find that we don't have any decipherable content. We can't actually even see where the handshake, sorry, the username and password's been transmitted, because it's actually encapsulated in SSH protocol or packet, which Wireshark can't decipher. So any content that we transferred using that session will also be quite secure, and we can't find file names, we can't find destinations, we can't pull content apart. So that just demonstrates the difference between an SSH encrypted transfer and I guess a non-encrypted FTP standard text-based transfer. So what we learn is, oops, we've shut down that resume slideshow. Okay, what we learn is all packets encrypted, username and password not decipherable. That's not 100% true. Obviously, if the protocol you're using, the SSH protocol, which as we know have been decrypted in the past or cracked in the past, if you use a protocol that has been exploited, then potentially you could be in a bit of strife if the machine is exploited as well, because these exploits require, I guess, local sessions. And transfer of text files and binary files are encrypted, so we can't even see where they start and end. We just see that a packet has gone through, its contents are unknown. Now this is what I'm talking about in terms of exploited protocols. Now SSL3 is exploited, so a session running on the host could potentially pull apart the SSL3 packet and see the contents. Fortunately, what we'll find is FileZilla version 3906 actually protects against the SSL3 exploit or Poodle exploit. The patch was released on the 20th of 2014. The patch is just disabling the SSL3 protocol, and it falls back to TLS 1.3. So, okay, what we'll do is head back over to the lab, studio.